A brief introduction of Ryan Sims. Ryan Sims is Lead R&D Engineer at the PNDC and manages research program relating to energy system flexibility and electrification of transport. Prior to working at the PNDC, Ryan worked for Strathclyde spinout company Smart Grid Solutions in the United Kingdom and the United States, working on grid integration of distributed energy resources. The PNDC, which is formerly known as the Power Network Demonstration Center, which is a part of University of Strathclyde, is a whole energy system test and demonstration facility. The PNDC helps industrial and academic innovators accelerate the development and deployment of novel energy and transport technology. Kindly join me in welcoming Ryan Sims for this month's technical presentation. Here you go, Ryan. You can unmute yourself.
Great. Thank you, Sagun, for the nice introduction. And thank you also to my colleague, Stephen, for inviting me to talk. So should I just get started?
Yes, please just get started.
Okay, great. And you can still see my screen here?
Yes, we can still see your screen here.
Great. Great, yeah. So thank you everyone for inviting me to speak today. It's really nice to be here, and especially to Stephen for organizing it. Stephen and I spoke a little bit about the topic that was best to cover here, given everyone's expertise, including my own. So what we settled on was to present a little bit about the research that we do at PNDC, looking at decarbonisation of transport and somewhat specifically electrification of transport, and then try and tie some of that research that we do to a sort of wider context of developing countries. So to be upfront, that my expertise is very much in the engineering side and of things, of electrification and decarbonisation of transport, and some of the considerations of the applicability of some of the work that we do for developing countries is just my own thoughts that I've put together for this presentation. And I'm by no means an expert in working specifically in technology adoption and innovation in developing countries, but hopefully it's useful, and I hope that you pick some valuable things up from the presentation. I'm not sure if there's a normal etiquette for your presenters, but my preference would be is if you have any questions, please just unmute and ask them as I go along. That usually makes things a bit more informal and we get more out of it. Or likewise, I think you should be able to raise your hand. I may not see it because I'm in presenter mode, but that would be my preference. So please ask as many questions as possible. So the agenda that I'd like to, excuse me, the agenda that I'd like to cover is very quickly to give a little bit more information on the background of the PNDC and who we are. I know that Sagun has already given a high-level introduction, so I'll make that quite quick. Then I'd like to sort of introduce why I think that the decarbonisation of transport is something very important for engineers like ourselves to be working on today, and the impact that it has on, or can have on the world and in different economies. Then, as I mentioned, I've given some thought and thinking to the work that we're doing at PNDC, and specifically in the UK, where I have most experience in this area, and tie that to developing countries and see what differences there might be, but also where the similarities are, that there can be transfer of knowledge. And then after that, I'll give a bit more of a overview of some of the work that PNDC has done in this area and give some project examples of where we've been doing work. So an overview of PNDC. So I've already been introduced myself, but yeah, I'm an electrical engineer by training, and most of my career has been tied in one way or another to Strathclyde University. So I studied my undergraduate and graduate degrees there in electrical and mechanical engineering. And after graduating, I joined a company that had spun out from the Department of Electronic and Electrical Engineering, called Smarter Grid Solutions. So they are a smart grid control company who created active network management control systems, which were designed and deployed to integrate high penetrations of renewable energy to balance their variability. And I worked at that company for just under 10 years and had great experience integrating large-scale renewables, but also small-scale energy resources. And through that experience, I was introduced in a couple of different projects to electric vehicle charging technologies, and we integrated them into our control platform. And I started to understand several years ago about how important electric vehicles in terms of combating climate change and reducing emissions were going to be. Not only that, but also that the way that we approach that challenge and some of the decisions we make at a policy level and then also an engineering level, how important they would be for sort of solving that part of our emissions as much as possible, or in the right way. So about 4 years ago, I joined the PNDC as a senior R&D engineer, and I was recruited to start a new area of research in electrification of transport. So bringing my background in flexibility and smart grid, a lot of the work that we've been doing has grown from that. So the PNDC as a centre was spun out of the same Department of Electronic and Electrical Engineering about 10 years ago, or exactly 10 years ago, if you trust our marketing department. So we were founded in 2013, at that time as a dedicated smart grid test and demonstration facility. And we were formed in partnership with the distribution network companies in the UK and the university's engineering department. More recently, we have been diversifying away from purely electrical power systems and smart grids into what we've called whole energy systems. So that's why here you'll see we call ourselves a whole energy systems research and development facility. And what that means is that we're looking at technology research and demonstration of not just electrical products and services, but also products and services that use other forms of energy. And by that, we usually mean hydrogen, heat, transportation, and then also whole energy systems, which means the assessment of how those different energy vectors interact with each other, or can be planned and operated in the most efficient and economical way. So our team at PNDC we have just under 50 staff, and that's combined or made up of quite a large percentage of research and development engineers. We are operated in partnership with our members, and so we have a group of members which is made up of the distribution network companies in the UK, but also other technology vendors who make products and services that sell into the energy industry. So we have different ways of working with people, which I hope that you sort of take away from today, that you don't have to be a member of the PNDC to work with us. So our members do run their own research themes and focus areas and projects with the R&D staff, but equally we are also what we call an open access facility, which means that any company in the UK or internationally can come work with the PNDC, access our facility. They could either do that in a commercial basis, or we can establish joint working relationships and apply for joint funding for particular project ideas. So the PNDC, what we offer to industry is that we predominantly do device testing and demonstration. So we take our partners and customers all the way from shaping their innovation requirements, identifying challenges based upon the real issues that they're facing in the real world, and use our expertise within our team, but also within the wider academics.
Sorry to interrupt you. Somehow I mistakenly transferred the host to you. Could you please transfer that back to me? We need to let in a lot of people on the waiting room.
What to do thing.
Sure.
Sorry, Chairman. Can you withdraw the co-host from Dr.
Unfortunately,
Ryan?
I can't do that. I've transferred it to
Just
him.
right click on the Zoom of the NSA Glasgow. If you right click on it, you withdraw the co-host.
Okay, let me.
Then you make him back you withdraw the host, then you make him back the co-host.
Okay, I will try to.
If not, I can let everyone in.
Yeah, just do that, please. Just do that, please, and then you can.
Yeah, but sorry, can we just because it will be distracting you,
Yeah,
Dr. Ryan.
we need to resolve this. Yeah.
Sure.
Yeah. So
I'm just trying to find. If you can tell me, I'll bring over my.
Yeah, and Chairman, can you just, if you right click on the three dots or just right click on the whole NSA Glasgow, the Zoom, and just withdraw you make yourself take back the host.
Yeah, trying to do that.
Is that done?
Yeah, it's done. Yeah, it's okay.
All right, so you can make the Dr. Ryan back. Sorry about that. Thank you.
No, sorry about that. Yeah.
And then you can give others too.
Stephen, I think that may have stopped my screen
I
sharing.
know. You can go on now. Yeah, you can go on now. I started. Oh no.
Okay. Yep.
Sorry, Dr. Ryan, I think you only make him back the last.
Let him go ahead. We are hearing him. It's okay.
Okay. Can you still see my
but
screen?
You can't share his screen, so you need the co-host. Just right click on his user and make him back the co-host. Yeah.
Yeah, you can go on.
Yeah, that's it. Done. All right. Thank you. You can make the ESCO back the co-host too. Thank you, sir.
How's that?
Yeah, that's fine. Please go on.
Okay,
Thank you.
great. No worries. Where was I? Yes, so we work with all of our partners and collaborators in these different areas. So we work with people right from the early stage of identifying their innovation needs, but then also sort of bringing them into our labs and doing device testing. So we have a sort of unique and fully controllable test facility with high voltage and low voltage test networks, which means that we can de-risk technologies in a safe and controlled environment in a way that you're not able to do in the real world. And we also have sort of systems validation capabilities with real-time modeling and simulation. Furthermore, we will then take people all the way out of our lab into real-world demonstration and support them in field trials, de-risking some of the innovations that we have worked on and through to business as usual deployment. So the areas that we work in sort of three main focus areas, as they're called. So advancement of power networks, which is where we founded ourselves 10 years ago. Decarbonization of heat, which is a new area for us that we've established within the last couple of years. And then finally, decarbonization of transport, which is where I work with my team and we will be talking about today. So within the decarbonization of transport, as we see it, we split that into two main areas. So that's both the electrification of transport and then also heavy duty propulsion. So electrification of transport is looking at the infrastructure and vehicles and sort of transition plans we'll all need to make to transition our transport from fossil fuel vehicles to electrified vehicles, and the heavy duty propulsion is focused more on drivetrain technologies. So we are establishing a new facility with drivetrain testing capabilities, which include large scale, megawatt scale dynamos to work with sort of niche, large, heavy duty vehicles, including trucking and buses as they transition to new types of battery, electric and hydrogen fuel cell hybrid drivetrains. So how do we do that, or how do we do our testing? So the diagram that you see on your screen right now gives a summary of the different capabilities that we have for testing and working with technology companies, and specifically transportation companies. So we have high voltage and low voltage test networks. By high voltage, we mean 11,000 volts, and low voltage, we mean 400 volts. So we have those configurable test networks that are representative of the real distribution networks. With the mock impedances that we have at our facility, we have a high voltage network equivalent of 60 kilometers and a low voltage network of around 3.6 kilometers. And that's comprised of both overhead distribution lines and underground cable networks. Working alongside those test networks, we have on-site generation sources. So that means rather than only operating a facility in parallel with the national grid, we can run a 1 megawatt 5 MVA motor generator set and island our whole facility. That means we are able to test far outside of the normal statutory voltage and frequency bands that you would see on the UK network where we're based. So with the motor generator set, we can configure our whole facility as a microgrid and test technologies as if they were deployed in a microgrid type scenario, but also in other electrical power systems that might have different frequencies or voltage conditions than we experience in the UK. On that network, we're also able to sort of throw high voltage and low voltage faults. We are able to sort of operate our fairly comprehensive real-time simulation network. So we have a 6-rack real-time digital simulator, which allows us to develop electrical power system and component models, execute them in real time, and then through our power hardware, this sort of tri-phase power conversion system, interface that real-time modeling environment with the sort of the real assets. So basically seeing how a modeled technology can interface with that sort of physical grid that we have. From a transportation perspective, that might mean that we're modeling one or more electric vehicles and then interfacing through this power conversion system, the grid impacts of those vehicles onto the real network, which allows us to sort of evaluate how they would respond or how high penetrations of electric vehicle scenarios in the future might impact the distribution grid. And then layered on top of all that, we have comprehensive communication and network management capabilities, including sort of 4G and 5G networks, IP, MPLS networks, and low-powered wide area radio networks as well, which means that you can integrate various different sensors and control solutions into our test environment. So moving on to the topic of today's presentation, the importance of decarbonisation of transport. This diagram I'd shared on the agenda slide, but it was really just to try and help the next few slides just to set the context of what we're dealing with today. So the data here is taken from the World Resources Institute, which shows the global greenhouse gas emissions by sector. And here you will see when you break down the emissions associated with energy into various different sectors, that globally transport makes up 16.2% of total greenhouse gas emissions. So that is a significant portion of industry that we're going to have to decarbonize over the next 30 years if we're going to try and meet our net zero targets that the world has signed up to. What's interesting there is that if you look at this global picture and then we look at the UK picture, which is broken down from
sorry,
this.
Ryan, can I ask you on the previous slide?
Pardon?
Sorry, can you go back to the previous slide?
Yes, of course.
So, I mean, you said transport is 16.2%. Is it 16.2% of the energy of the total emission?
Of the total emissions.
Okay.
Yeah.
Thank you.
So if you look at that on a country by country basis, that's going to look somewhat different. In the UK, our transportation emissions are actually a much greater percentage than the 16.2% we have globally. And there's a couple of different reasons for that. So in the UK, we have 28% of our emissions, or in 2018, at least, that were associated with transport. So one of the reasons for that, as you can see, is that the UK has made significant progress in terms of decarbonizing the energy sector through there's a number of reasons, but the phase out of coal, even though a lot of that coal has been transitioned to gas plants, which are still fossil fuel based, they are lower emissions overall, but also the significant deployment of onshore and offshore wind, and to some other extent solar energy, means that our energy sector has been decarbonizing. In parallel to that, the transport emissions have been relatively stable. So as a percentage, you can see that it's quite a stubborn industry so far to decarbonize. And if you look at the adoption of solar and wind and other technologies compared to the adoption of electric vehicles or other alternative source vehicles, the transportation adoption curve is sort of significantly behind those other renewable generation technologies. You would probably also see something quite similar if you had a breakdown of energy for heat. So decarbonization of heat is another big challenge that's going on right now, but there's been little progress made there compared to sort of renewable energy generation deployment. So that's important for a couple of reasons. One, it's still a significant portion of our emissions, but also, as I'll highlight later on some later slides, the interlinks, or as I described earlier, the whole energy systems picture of energy and transport are interlinked in a way that you have to look at these issues together. So, yeah, so if that's the emissions side of things, which I think, or I assume everyone on this this call is fairly familiar with how important that is to solve. Decarbonization of transport there's significant other benefits that can be sort of our co-benefits that we will see if we're able to transition away from fossil fueled vehicles, and not only fossil fuel vehicles, but away from purely personalized fossil fuel vehicles. So this quote from Grant Shapps, who is the Secretary of State for Transport, is highlighting that transportation is so integral to our lives. It's not purely how we get around from A to B, it's also fundamental to the experience of how we live. So if you think about trips that you go on, why you're going on them, some of them are a bit boring, going to work and commuting, but it's so integral to your daily life. Other ones are fundamental. We travel for pleasure and for holidays, really importantly to visit families, and we need to be aware of all these different factors when we're looking at solutions in the future. If you look at this from an urban perspective, so the population of the world is continuing to become more and more urban as we move into denser and denser cities. The impact of transport is significant on the quality of life that we'll experience in those cities. So if you have one mix of transport modes in a city versus another, it could be a very different city. So you could have better air quality is also associated, so not just greenhouse gas emissions, but local air pollution and air quality indexes is really important as we transition away from fossil fuel. The improved health benefits of that, so improved health benefits of air quality are on a personal level and also on a societal level, means that as we start to decarbonize transport and improve our health, there will be significant benefits to healthcare costs, to life expectancies. And furthermore, if you look at some of the lower tech solutions that people are proposing to decarbonize transport, promoting active travel and sort of smaller shared or active travel in public transport, essentially you'll have health benefits from increased activity and walking and cycling, which combined with the air quality could have significant benefits for society as a whole. Optimized resources is another co-benefit. So as we're looking at the net zero challenge as a whole, competition for resources is going to become more and more critical. So the same hydrogen that you might need for a low carbon vehicle could also be required for grid scale storage that could contribute to the balancing of the electricity system as we have more variable renewable resources. So as we look at not just the shift away from what type of fuels we're using, but what modes of transport we're using, we need to consider that again, whole systems perspective and optimizing resources, because the resource competition that we have globally right now with fossil fuel markets is going to transition into new types of minerals and resources and fuels, and it's essential that we consider that when we're planning our future transport systems. Making or reduce inequality. So what's evident from a lot of different studies in cities all around the world is that, like a lot of the impacts of climate change, the impacts of air pollution related to transportation and especially in urban environments are usually felt by one, those people who are least responsible, and then also people who are who typically have lower incomes. So as we sort of transition to electrified and decarbonized transport, the inequalities that those people are experiencing should hopefully be reduced. And boosting economic efficiency. So a lot of our transportation today is incredibly inefficient, not only from a perspective of how much fuel you're using to get from A to B, but also in terms of how much space you're taking up. So if everyone is traveling in a single vehicle from the same point A to point B, you have incredibly congested roads, and that congestion creates delays which will impact upon moving goods and services and people around, which is essential for development of a strong economy. So it's essentially, if you have poor transportation planning and congestion, you're undermining some of the infrastructure benefits. You might have invested in good roads and bridges, but if they're congested, you're not getting the benefits back from them. And then the top left one, I think ultimately is just making cities a better place to live. If you've been in low traffic neighborhoods and seen some of the initiatives in countries like the Netherlands or some of the pilot schemes that are happening throughout the UK, personally, I think most people would agree that these are nicer places to live and to spend time with our families, rather than in congested places with lots of fossil fuel emissions and particulates that can damage our health. This is tying in a little bit to a slide I'll also talk about later on, but that point about the inequality that sort of transportation particulates have on different populations and where we are today. So the World Health Organization in 2019, based on local air quality monitoring and working with governments all around the world, has highlighted that they think 99% of the world's population is living in places where the air quality guidelines that they have set, or that the international community has set, are not being met. I know, for example, where Stephen and I live in Glasgow, that our air quality regularly breaches the recommended guidelines of particulates, and that's not something that we want to see continue. Why does that matter? It matters because those that outdoor air pollution has a direct link to health. So from the same World Health Organization stat, they estimate that 4.2 million premature deaths occur worldwide on an annual basis, and of those deaths, 89% of them occurred in low and middle income countries, with the greatest number of them globally being in Southeast Asia and Pacific regions. But it is a global problem. Like 99% of the population have this issue. The graph on the right-hand side, you'll see in terms of particulate emissions and measurements where some of the most polluted cities are. So relevant to the group today, a number of those cities are in Nigeria, in Pakistan as well, and where else? China as well. So that's something that impact on those local economies will be felt further down the line as the population's health is poorer, and it will have knock-on effects of cost to the social healthcare system, but also to the general output of the country. So when we're thinking about different solutions of how to tackle this, I've tried to break down into these different market segments to provide a way of thinking about it. So I'm getting some feedback. I'm going to see if I can. Yeah, I've tried to break this down into market segmentation. So the increase in walking and cycling, that's pretty straightforward, but especially in urban environments, the promotion of active travel is going to be critical to our transition to decarbonisation transport. So how can we do that? That's usually on the policy and regulation side, but also an infrastructure side. So we need to create the infrastructure required for people to adopt active travel. So in cities, that might mean bike lanes, it might mean different street layouts and designs. It might mean creating pedestrian zones that cars and vehicles that don't need to can enter. That's quite a contentious issue. So that's, I think, one of the reasons why this has been quite slow to be adopted all around the world. The next top row in the middle, the zero emission fleet of cars, vans and motorcycles. This is the one that I think everybody thinks of when we talk about decarbonising transport. So that's the adoption of electric vehicles, electric motorcycles, electric vans and trucks. That's something that I think most people are starting to become familiar with. I'm getting questions from lots of friends and relatives now that I didn't even 2-3 years ago about these types of technologies. And when you look at the breakdown of emissions, that's actually a really large segment of the emissions that transportation as a whole has. Then the decarbonising how we move our goods about. So that's from a domestic sort of trucking and distribution perspective. That's something that I think requires good coordination from a government perspective. There needs to be good signposting as to the types of infrastructure that are going to be available, so that freight companies can start to plan for the transition to new types of low emission fleets. So in the UK, I think there's been a poor sort of quite a relatively poor vision created by the national or the Westminster government as to how fleets and freight should be decarbonising. Should they be planning for hydrogen-based trucks? Should they be planning for battery electric fleets? Should they be planning for some type of electric rail system? And that's something I think that looking at how we can improve the situation and accelerate this change, we need to create those sort of stronger signals from central government. Decarbonising railways. So for countries that do have rail systems, it's one of the quickest and easiest ways that you can reduce emissions from transportation is by electrifying rail. So moving away from fossil fueled engines to electric rail. That's a very well-established technology. It's proven, it's relatively straightforward to do. It requires infrastructure investment and finance, but that's something that people are working on. The other part of decarbonising rail is that I've know a group from St Andrews University have been working on has been a battery electric rail locomotive to essentially bridge the gap between areas where it's feasible to provide direct electrification. So if you have a gap, you could rely to some extent on battery powered or battery storage on those locomotives to power your train until you get to the next electrified rail lines. And then the bottom two, the acceleration of aviation decarbonisation and maritime decarbonisation. I've used the word accelerate there because in aviation, from my own perspective, there are solutions that are being discussed in terms of sort of biofuels and synthetic fuels for aviation, and even on a very small scale for lightweight aircraft, electrified aircraft, but on a large commercial passenger aircraft and sort of freight distribution aircraft, there do not really seem to be any viable technologies that are going to arrive soon that are going to sort of reduce emissions or completely remove emissions from that sector. So from a net zero perspective, that means that we need to do as much as we can to reduce demand where that is feasible. Although that's something that's from a passenger aircraft perspective is going to be extremely challenging because we live in such a global interconnected world. I have family on other sides of the world, and it would be very hard for me to imagine giving up seeing them even on a yearly basis. So we need to be looking at reducing our emissions, looking at incremental changes we can make there, and then look at offsetting, which comes with its own whole set of challenges as well. Likewise with maritime decarbonisation, that is its own sector, and it has a huge contribution to global emissions as well. And the companies who work in the maritime shipping sector there's a small number of extremely large companies that need to work to transition away from sort of the low grade bunker fuels that they're using today, which are extremely low cost, but emit a lot of both greenhouse gas emissions and particulates. That's something that feels a lot more solvable from my perspective. If you compare that to the challenge of decarbonising aviation, I think that the maritime decarbonisation is something that we could solve if we have the will and the right people researching and developing those technologies.
Sorry, Ryan, how much time do we have to go with the presentation? Just a quick question.
I would say probably about another 10 minutes. How long do you have?
Okay. That's fine. 10 minutes, okay. 10 minutes.
Okay, great. Yeah. I'll keep that quite quick. So relating to those different segmentations, I think the energy supply and fuels is something that's extremely important to bear in mind. So if we're transitioning away from petrol and diesel fuels into alternative fuels, we have the primary one we're looking at is the electricity grid, which is backed up by batteries. So that has significant implications on how large an electricity transmission and distribution system we have. We're going to have to make significant investments in the transmission and distribution of electric power to those electrified transport loads, but also we're going to have to start mining new resources for batteries. And that's something that from a domestic side, every country should be thinking about how they're going to be manufacturing those batteries. The biofuels option for replacing fuels is appealing because quite a lot of the combustion engine technologies that we have today can operate on biofuels, and that's appealing because it would minimize the impact on the manufacturing of those vehicles. We could utilize a lot of our existing knowledge in those areas. However, biofuels have come with their own set of challenges, both environmental challenges of where we grow the crops for those biofuels and some of the impacts that can have on local people and on local environments. So I think there's still a lot of questions around if that is actually a scalable resource. And then hydrogen is the other one that you'll see talked about. If anyone has works with hydrogen, that you'll know there's various different types of hydrogen. So hydrogen is used in our economy a lot already today, but that's predominantly grey hydrogen, which is made from sort of fossil fuels and steam reforming fossil fuels, which outputs carbon. So it's, while it can be a zero emission fuel at the point of combustion or consumption, it does have emissions within the process. Blue hydrogen is similar, but involves some element of carbon capture and storage, and that's seen as a near-term viable solution to sort of scale up the levels of hydrogen people are talking about. And then green hydrogen is hydrogen that's made via the process of electrolysis, which can be classed as truly low carbon if it's made by the generation by renewable resources. That then sort of creates significant questions around how we use and move and operate vehicles with that hydrogen. So hydrogen is can be problematic because of the pressures and temperatures and energy density that as a fuel it has. So green ammonia is another solution that's talked about, where that's the process of where from green hydrogen you can combine that green hydrogen with other elements under pressure and heat and create green ammonia, which is a much more energy dense fuel and doesn't have the same challenges of needing to be pressurized or kept at such cool temperatures as hydrogen for the same densities. So if you look at the market segment of shipping, green ammonia is something that could be quite an exciting fuel. And why are those fuel choices and decisions interesting? They're interesting because the sort of efficiencies that they have are particularly sort of relevant to the different technologies. So the battery electric aviation, for example, is going to be an extremely challenging technology to develop because of the weight implications of the batteries we would need to fly vehicles. However, the hydrogen and ammonia alternatives could be lighter weight. However, this figure exemplifies the impacts of choosing certain fuels for different transportation means over another. So you may have seen debates online about if we should be transitioning from electric cars, which have drawbacks in terms of their time to charge and also their range, versus hydrogen cars, which can be quicker to fuel and have longer ranges. What you see here is the various different processes and what people call well to wheel, which comes from the oil well to the wheel efficiency. It's an old term, but here it's talking about the sort of electron to wheel efficiency, where for electric cars, you basically generate electricity, transport it through a very efficient national grid, charge that to a battery, and then sort of fuel an engine with losses at various different aspects along that. You can have efficiencies up to 90%. if you look at hydrogen cars, there's a number of other intermediate steps or transformations of energy molecules and electrons, which when you add them up have an overall efficiency rate of 25 to 35%. So I think what I wanted to highlight from this slide is that that is important, because if you have the option to electrify a transport mode and it seems viable, then doing that over hydrogen does seem like a good solution. However, I definitely would not write off hydrogen-based vehicles for all modes of transport, because there's certain modes of transport that just will not be able to sort of be electrified, because they might be extremely remote or require extremely heavy fuel densities that can't be sort of met by battery electric vehicles. The infrastructure considerations, so I'll maybe skip on past this just to some of the considerations relating to developing countries, and then I'll pause there. Sabine, does that work?
Yes, that does.
Yeah.
Thanks.
Okay, great. So I think considerations relating to developing countries, so hopefully that has set the context of different aspects of what engineers and policymakers need to be thinking. From a developing country perspective, I think national and local policy, similar to the comment I made about the UK government, it's essential that at a national level and also a local level, there's very clear sort of roadmaps sort of set out that the government sort of lays out to give clear sort of indications to industry and to local governments and councils and people who own fleets of vehicles, and also the local populace, what they should be doing and where they should be investing their money and what type of infrastructure they can rely on in the future. Data and baselining. So something that within my own job that I've been doing a lot of different projects in with my colleagues at the PNDC is it's essential that countries all around the world need to sort of create new data to be able to baseline where we are today with transportation. And as that transition away from fossil fuels to these new types of vehicles happens, we're going to need really good data sets to decide where that infrastructure should be placed, how large it should be, when it should be deployed. And that's required to sort of optimize the planning process, but also to provide evidence to some of the financial institutions that might have to underwrite this infrastructure change. So I would say data and baselining, and people like in developing countries, that's something people should be thinking about early, so that they can use that to inform planning decisions and investment decisions. A really good example of something that we've done is we have been working with 3 local authorities in the north of Scotland, trying to help them optimize the location of electric vehicle charge points for public vehicles, looking across various data sets of where is their capacity on the electricity network, where is there land that could be developed, where is there demand from people who have or might want to have an electric vehicle, and using all those different data sets to inform those decisions. The infrastructure requirements. So the infrastructure required to deliver the electrons to electric vehicles or molecules to other alternatively fueled low carbon transports is going to be significant, and we need to be sort of investing heavily in the national infrastructure that's going to enable that. That's both from the generation side. So if we're going to rely on electrified transport, the electricity system has to be decarbonized, and we need to be investing on a large scale on renewable energy, and then also in a grid infrastructure that can move that renewable energy into cities and to where the demand is. So it can't be underestimated the scale of infrastructure investment that's going to be required to enable that. Standardization and regulation. So it's because these new technologies are evolving, there are still debates being had about which sort of components and connectors and protocols are going to be embedded within the vehicles and the charging equipment and the transport technologies that are going to enable this transition away from fossil fuels. So I think from a developing country perspective, it's definitely essential to sort of engage within that international standardization process, and also to sort of learn from the mistakes that have already been made, and potentially some more sort of developed countries that that have been sort of trialing technologies for 10 years. And there's obviously an opportunity there to not only sort of catch up, but also leapfrog some of those mistakes that have been made in developed countries, as has happened with other sort of low carbon technologies around the world. Supply chain. So it's, if you think about from an economic opportunity perspective, this transition and the new types of vehicles and infrastructure that are going to be deployed present a huge economic opportunity for countries who can supply the vehicles, the fuels, the raw materials into these technologies. So I think it's essential that all countries start to think about how they can develop that supply chain internally, relying on sort of even sort of your sort of close collaborative countries to import their technologies is going to be challenging, because there's going to be such competition for resources. And I think getting actual access to vehicles is probably one of the biggest challenges for developing countries right now, because globally we're in a sort of supply constrained market for electric vehicles and batteries. So developing as much of that local supply chain as possible would help alleviate that. And likewise, I think for finance, I think this infrastructure requirements I outlined already are going to require large amounts of investment, but also some of the ways in which companies and people purchase transport technologies or even move around is being changed. I think a really good example is the cost of an electric vehicle. So the cost of an electric vehicle can, if you look at it from some perspectives, be on par with a fossil fueled vehicle. However, a lot of the costs of that are upfront, because you're investing a lot of money in the battery that's within the vehicle, but then your fuel costs are very low. So that creates a barrier to entry for a lot of sort of lower and middle income people, where it's only high earners who could purchase an electric vehicle. So if you can have innovative financing mechanisms for leasing or spreading that capital cost across the lifetime of the vehicle, that might be a way to accelerate adoption of those technologies. Reliability of infrastructure, I'll skip over that quite quickly, but as we're investing in this infrastructure, a thing that we've saw in the UK is that because it is there's new technologies here. I think electric vehicle charge points being a classic one, that reliability of that infrastructure is not good enough, and we need to be ensuring that it's regulated, it is reliable enough for people who are using it on their day-to-day lives and need it to be working. Geographic considerations and transport costs. So I think for areas that might be extremely rural, there's a huge opportunity where electrified transport could actually be much more economic than fossil fuel transportation, because it's easier if you have a local grid on site or can generate sort of renewable electricity locally and use that to fuel various transportation modes, that there's a huge opportunity that you could sort of be a lot more efficient and economic than if you were having to ship fossil fuels from a sort of another area to then refuel local vehicles. And then the final one I would just like to highlight it before I sort of hand back over or open it up to questions is just skills for the transition. So there's new types of skills that are going to be required, both from an infrastructure perspective, but also from a vehicles perspective. So even down to the mechanics that are operating on fossil fuel vehicles today, they will have to be retrained and upskilled to be working on electric vehicles. So I think highlighting that both there's new skills that need to be mapped out on a country by country basis, but then also the volume of people. So again, it's down to that scale and pace of change that is going to be required. So the people who are going to have to install electric vehicle charging equipment, maintain that electric vehicle charging equipment, is going to be orders of magnitude higher than what is being done today. And if we don't have the right skills and people coming out of high school, college, universities, then that's going to be sort of a delay or a sort of constraint on our ability to make that transition. So I'll pause there. I'd like to thank everyone for listening and look forward to any questions and a discussion about the topic.
Thank you so much, Ryan. This is quite a very rich presentation, touching about so many infrastructure, touching about policy, regulations and all that. So I know we've spent quite some time, and thank you for your patience for your time. Please, if you have any question, can you just indicate by raising up your hand? We probably will take between 3 and 5 questions if there are. And if not, we will. Any questions? Anybody? Show of hands. Yes, we have a question from Kelechi. So Kelechi, can you please, Kenichi, can you please unmute yourself and ask your question? Thank you.
Yeah, thank you very much.
Yeah.
Okay, sorry. I joined here with someone else, so that's what's causing the interference. Thanks for your presentation. My first question is your thoughts on how developing countries can leapfrog the infrastructure problem. If just your thoughts on it, because we don't currently have the money to invest in maybe expanding the grid to accommodate the need for electric vehicles. So what are your thoughts on how maybe we can leapfrog the infrastructure problem, in terms of decarbonizing transport system? Number 2 is on the whole green energy ecosystem. And I know that the power consumption of extracting and processing lithium, for instance, for electric batteries, is currently outrageous. So that's not really very green. Are there new technologies that are coming online to try and make this process less energy intensive and actually deliver the benefits of decarbonized transport? Thank you.
Thank you so much, Kenichi. So maybe Ryan can give some quite brief answers to that. Thank you. Sure.
Yeah, thank you, Kenichi. I think they're both really great questions, and I definitely don't have the full answers to either of them. I think on I answer the second one first, so the sort of the green nature of some of these modes of transport that I outlined today. I think the minerals that are going to be required, not just for vehicles, but for batteries that are going to go into various different technologies. I think those are real concerns, and I think that there's a few things that people need to bear in mind. One is that I think the data and baselining that we need to have is you need to look at the whole life cycle emissions and impact of different technologies. So I think in some ways, while there's very fair concerns about working practices and environmental impact of mining of some of these rare earth materials, some of those are, if you were to monitor where your materials were coming from and to try and incentivize good practice, as we've done with other manufacturing and provision of goods in different sectors, that could have an impact. And then also looking at the sort of life cycle benefits of a whole vehicle. So what we need to already start thinking about is, well, if a vehicle is going to last for 10 years or 15 years or 20 years, if we're lucky, what is happening to all those minerals when they when the vehicle comes to its end of life, can they be recycled and repurposed into the next generation of vehicles? And how are we assessing like each transport mode across its whole life cycle of emissions? I think the other thing that we need to bear in mind is that an electric vehicle is definitely not zero emissions over its whole life cycle. There's a lot of embodied emissions in the manufacturing process. So it goes, I think the best way to summarize that, it goes to that hierarchy of what should we be doing. I think you see some people lay out this pyramid of transportation where the first thing we should all be doing if possible is active travel. So walking and biking if possible, and then it's public transportation, and then it's shared transportation. And only if we get to no other option or alternative, we should be using sort of private modes of transportation and vehicles. And I think that's a mind shift for a lot of people, but that's one way that you can reduce your requirement for mining, is by not driving as much or not having as much ownership of vehicles. But it's really complex, I think. I wish I had more of an answer there or solution there. On the local, the sort of leapfrogging side, I think that's something I think for today, definitely both to Stephen and I at the PNDC, we'd love to sort of collaborate with people on options for that. Some of the initial ideas, I think, for people who definitely don't have that grid infrastructure, if you live in an area that has sort of unreliable or even no grid infrastructure, and you're reliant on local diesel generators or even small scale renewable microgrids, you're also usually sort of relying on fossil fuel transport today. You either have no transport, or you are relying on fossil fueled buses or even motorcycles to get around. You're having to ship those fuels into those typically rural areas, which is expensive, and sort of the costs of that fuel is very dependent on market forces and unpredictable. If you were to electrify some of those same motorcycles or public transportation modes and be able to charge them locally using those same microgrid resources, I could imagine that could reduce the total cost of transportation and create better links between those areas that need development with the sort of cities that have a lot of the commerce and markets and economic like work opportunities that they want to access. So that would be one idea, I think.
Thank you so much, Ryan. Any more questions? In the absence of any, I will hand over to Engineer Steve Ugwai, the branch chairman, to kind of give a short statement. We will be moving on from the technical webinar or presentation